Good day, and welcome to the Plant Engineering Webcast, Creating an Effective Plant Management Strategy in a Post-Digital Era, brought to you by CFE Media and Technology and sponsored by Infor. I'm Kevin Parker, editor of Plant Engineering Magazine. Here are some tips to help you get the most from today's webinar. If you're experiencing issues with your slides or audio, refresh your browser or click the Refresh Media button directly under the presenter's picture. If you are having technical problems with audio or the slide presentation, click on the question mark at the top right-hand corner of the screen to access a list of system checks to try before contacting an online technician. If you do need a technician, type a message in the Ask a Question box and someone will get to you as quickly as possible. Use the Ask a Question box to type questions for our speaker as well. The live Q&A session will begin after the presentation concludes. Today's webcast is being recorded. You will receive an email within a week with a link to the on-demand event. To download a certificate of completion, a PDF copy of the presentation, and other additional resources, use the Event Resources tab on the left-hand side of the screen. Those documents will also be available with the on-demand version of this webcast. Now we will hear from the sponsor of today's webcast, Infor. At the conclusion of the video, you may experience a few seconds of silence to compensate for varied internet speeds. Please stay tuned after the video for the presentation. Welcome back. I'd now like to introduce today's speaker, Kevin Price. Kevin has more than 20 years of experience in the enterprise asset management solution area for Infor. He's served in multiple leadership roles in sales, service, development, and product management. He is currently the technical product evangelist and strategist for the Infor EAM portfolio, which includes EAM, MP2, and Spear Technologies. Kevin is based out of the Infor EAM Development Hub in Greenville, South Carolina. Thanks for joining us today, and please go ahead.
Hello. Thank you for coming out today. Hope that you're going to enjoy today's session. We definitely think it's going to be a great one for you. We have a couple of objectives that you can see on here. Understanding a bit of the new era of complex machinery. We have a lot of difficult machinery out there today. It's not as basic as it used to be. It tells us more about its health. It tells us more about its condition. And understanding what interruptions are is important because you need to understand why uninterrupted is essential to what you do. And that goes around risk analysis and condition assessments and a lot of different stuff we're going to talk about today. Other areas of how stakes continue to rise, best practices evolve, different ways that EAM solutions that are modern really handle this kind of stuff, and then how to get everyone on the same page of a complete different strategy towards moving forward into this new era of post-digital. So if I take a look and say, okay, what is this? What is the post-digital era really? I mean, what does it mean? Well, is it the AI-enabled machinery. So artificial intelligence-enabled machinery. Is it things that are going to have machine-to-machine connectivity? Is it going to involve the connected things approach of the Internet of Things approach? Is it going to bring in large data sets, small data sets? And the answer is unfortunately yes to all the above. If we look at the paradigm shifts that we've had over the years, and this is classified in different ways, Industry 1.0, 2.0, 3.0, and 4.0, we can see the evolution of our equipment itself and the types of data that we capture about that equipment. If you look into where it's at in Industry 1.0, you have mechanization coming about for the first time, steam-power driven pieces of equipment, as you can see in here. The mode for operation of asset management, of course, is reactive. So when it breaks, you fix it. And that's pretty much it. And we always jokingly say it around the development environment, at least for EAM, is the first asset management came about when the first wheel was made because that thing broke. Someone had to fix it. And they tried to fix it and had to make a new one, so they had to replace it, had to refurbish it. They had to go through their own life cycle assessments, but it wasn't as complex. It wasn't as detailed as we have today. It's really pretty basic. So in this environment, it was easy to train technicians. It was easy to train people how to operate it. It was easy how to be able to expect cost because really stuff breaks, you fix it. And you pretty much over time kind of get an idea of what happens and what to get. So it was really pretty basic in what it did. And we still have assets that are out there that operate that way. And you will always have assets that are out there that handle that way. So things moved forward, right, into mass production, assembly lines. We had new energy components come that were not done from steam and not from different power, things like that. So we had different elements that we had to be prepared for, new maintenance methods. We could actually do preventive maintenance now. So that was not just fix it when it breaks, but I can actually run this for a certain period of time and then do some things that are preventive so I can prepare for an ultimate failure. If on an assembly line there's a lot of rollers, there's a lot of different types of gaskets, there's a lot of different types of conveyor system components, and I know I have to lubricate those at a certain time. So this idea of different maintenance patterns came about. And we prepared ourselves as a society and started building out what those costs could be, because if I knew that I'm going to have to do X type of work every 3,000 hours, then I know that this is what I'm going to need. And again, if it's a mass production, a critical failure in that line, man, everyone shuts down. They can't move. They can't function. They've changed over the long, but because of that, you didn't have basic engineering needs anymore. It started to grow. You started to have people that needed to know different types of disciplines in engineering, basics of mechanical and electrical and things like that compared to today's standards, but it wasn't a jack of all trades anymore. If you look at the next stage of Industry 3.0, here's where you're bringing a lot of component elements, some computer-driven types of stuff, some human-machine interfaces. You're bringing in, this is, not within the lifetime of everyone here, but it's in the majority of the lifetime of people here, especially like me. You're looking at assets that you can get data from on a regular basis, control, and they became specialized assets, very specialized in not just their customization and personalization, but generic offering in their operation. So I still have a jack of all trades. They're coming in, doing their job, but they're not able to get up to speed in some of these more technical components. And I need to bring in specialists now that just handle that. Or even better, or even worse, depending on how you look at it, I have to outsource this now to an OEM, the original equipment manufacturer. And that could be a good thing. Because I can get a service level agreement and negotiation for that. It may not be a good thing because the cost could be so prohibitive. Now I'm inking into what I could do in terms of what I would get in revenue for that or availability for that even. So there's a lot of issues that could come about. Now we bring about Industry 4.0. Here we have a lot of the basics, right? We have a lot of the general types of works that we would do in engineering. We have some computer models that we come into it, but we're looking at things from different data sets, different views, different lenses. We have big monitoring systems that produce billions of records on an hourly basis. How do I even survive in that deluge of data? How do I make sense of any of it at all? And even if I could, I don't know that I would, because it takes too much time out of my day to figure it out because I'm not really up to speed. So I have no choice. I have to bring in an original equipment manufacturer. I have no choice. I got to bring in a data scientist now. And is that a bad thing? It may not be. It depends on your business. It depends on what you're looking at. It depends on how you're running. You really need to understand what your assets' vision is, right? So you understand what its purpose in life is. The more you can go back to basics of understanding what reliability means, the impact to reliability, the impact to availability, understanding that asset as well as you can as it applies or affects or produces the product or service that you produce revenue for, you'll start to understand where to spend money and start to understand where to invest in. And unfortunately and fortunately at the same time, you'll have a lot of data to do this now. In this particular day and age and this evolution that's coming about, you've got a deluge of it, and you can be able to really dig into it. So if I'm sitting in a CEO seat, I'm thinking in this post-digital era, what's important and where's it at and where can I do my best. So understanding and taking these data sets and embedding them into the right places is going to be very important to me. Number one, embedding the IoT-based technologies pushes demand for EAM to analyze the business functions. So as I start to embed those data sources into my EAM practice, I can understand the data, I can understand the process, I can normalize the process, I can automate the process even, and I can do more with it. Pushing it all into the cloud almost becomes a no-brainer at that point because you have to. The data size alone demands it. Being able to push it into somewhere where it's safe, you don't have to worry about what that hardware component is going to fail. Is it not? Is the switch going to be available? Is it not? You do need to worry about getting to the web, right? So a connection that's reliable and strong is there, but it doesn't always have to be a landline anymore. I mean, we believe firmly in our approach that one of the most unnatural things you could ever see in your life, in enterprise asset management circles at least, is a technician that's sitting behind a desk. And that's because he or she does what they do best in the field. In the field, fixing equipment, inspecting equipment, doing condition assessments. That's what they do. That's what they're good at. So you have to have answers, solutions, form-fitted for that particular view. So as you start to get data sets put in for those assets, because that's what they do, remember you have to get form factors as well, and there's a lot in this post-digital era of understanding what you can bring about. Down into the emergence of service-based business models, servitization of equipment, servitization of data. I'm embedding these sensors, and I'm getting equipment that has more and more data sensitivity to it. But again, I may not understand it. So I may have that data set outsourced. I may outsource it to the OEM. I may outsource it to an engineering firm. Some people get colleges and universities involved on a regular basis because the engineering just simply isn't in their environment where it's at, and sometimes it's not even in the college and universities. But being able to pull that in is important. Adoption rates and partnerships with ERP vendors are always important. This is the basis to EAM success in and of itself in this era especially, is working in collaboration with all the other departments and all the engineering sets. It's something that you have to do from the ground up. If you don't, then you'll start to look at duplication, triplication, quadruplication of where data lives and how it functions. And when you look at it from that perspective, at least from a high level, from a CEO perspective, it's not a good thing. So if we think about this idea in a post-digital era, we're doing asset management, we're doing reactive, we're doing preventive, and now I'm getting this data in. So I have IT data and OT data, so it's operational data, and then information technology data that's kind of overlapping between the two. There's a convergence for it. And this particular review is showing an example of where all those come into a mix in this Venn diagram. But the idea behind it is these IT/OT have been overlapping for a long time, and they're overlapping more and more and more and more every day. So as you start to get your assets in, new equipment in, as you start to get new anything in, it's more and more and more digital. So what do you do with that data? How do you interact with that data? How do you plan for that element? That data is the biggest blessing and could be the biggest frustration at the same time. So if you look at it as a blessing and what you can do with it and plan for it and understand for it, the better off you're going to be when capital asset planning initiatives come around, because you're going to have the data set to really fully defend what you're asking for in your operation budget. It'll be a strong opportunity for you in this post-digital era. Other things that can be problematic in this piece, though, is the big data we've talked about, the connected devices we talked about, industrial apps we talked a little bit about. The edge computing and reality, augmented reality and digital twins are becoming a lot more popular. We've seen them for a while. We do a lot of it out of the box with some building information models through some CAD solution help that we have with a wonderful partner. But we also do other things, too, with augmented reality. We have done basis of augmented reality before. We've done some very basic stuff. We've done some advanced stuff. But this post-digital era allows you to bring that expertise on the asset if you don't have it. Certainly, the asset can tell you its condition and may be able even to prescribe to you what to do to fix it. But you may not have a skill set. So an augmented reality opportunity could exist where you could bring in an engineer that may come from the original equipment manufacturer to help guide you where to go, guide you what to do. You could be on an oil platform in the middle of the Gulf of Mexico, for example, trying to work on a piece of equipment that you have an understanding for, but you don't have as technical understanding as someone that's a specialist in this area. Well, they can be back in New Orleans or Baton Rouge and connected to them through goggles, through the augmented reality view to help identify what to do, what to fix. And that view can also give you a sense of what's broken through a 3D image. So there's a lot that you can do in this post-digital era. The question is where, when, what pieces, what types of processes that you use. And that's a question of, what's important again. Go back to the risk model. Understand your assets as intimately as you can. Understand when they run right, what happens. When they run bad, what happens. When they fail, what happens. And then start to apply the types of methodologies that you can. Basic ones that you have in condition monitoring has an evolution as well. So if you think about the evolution of a condition monitoring event, we would set up a long time ago the periodic collection of stuff. So I would go out to a work order. I would write in the notes, here's what I found in the oil analysis, here's what I found, and by that there may be some filings of metal that shows an image of gears grinding as an example. I could see where the bearings have been packed with oil too many times or lubed too many times. The Zerk fittings are coming off. There's different types of issues that go on that are visual. Then over time, we start to rely on some of the stuff through monitored systems. Again, the evolution, that 1, 2, 3, 4, is also an evolution within condition as well. So not only can I capture this kind of stuff, but as I start to evolve that, I could pull it directly from the data, coming from the sensors. I can pull it from a PI system. I can pull it from a number of monitoring systems to take that data in and write an algorithm on top of it to tell me what to do, to how to fix it, to how to repair it, and to how to build it out. That's really why we see this implementation methodology of predictive maintenance. So on the far left, you have sources of data that are coming from various places, databases, historians, different types of grids, different third parties that come in, bringing it into EAM so that we can be able to see it. It doesn't have to necessarily come to EAM, especially if it's a large data set. We can put it out to the cloud, the data lake. That's another problem. But being able to go in and normalizing it, putting a grid to it so I can understand what to do, and then from there I can be able to put alerts, I can put work order creation, I can put email notifications, I can put physical notifications. There's a lot of different things. And that's what we've always done around predictive maintenance, is we've used a lot of these tools that are in EAM to help build out that type of prediction and condition-based approach. And when we do that, we can put in algorithms, we can put in learning mechanisms that can predict failure over time. So I can see when that asset is slowly going to degrade. And I can see troughs and valleys in that degradation that may be because of certain operation. Climatic conditions could be due to energy consumption reduction initiatives. There could be a lot of different things that go on to it. But I can start to inspect that on a regular basis. I can start to pinpoint it on a regular basis. I can start to get very specific. And then once I can look at what I can do to really identify that and process it, I can put more data to it. I can put SCADA systems. I can put Internet of Things systems to it. I can put artificial intelligence to it. I can put visibility behind it. It is something that builds on itself over time, because in the predictive world and condition-based world, it does need data. It doesn't have to have data, in at least a deluge of it, but it does build upon itself. And this is something that we've learned over the time in the post-digital era that we're going to have a lot of. A ton of data coming from different places. If we don't start building that process, start building that house from the ground up correctly, having the right structures, having the right people holistically involved in what reliability means and what condition assessment inspections mean, we're not going to get to this point of automation in a very solid way. It could be very bumpy. and we were going to have to rely on more people to get involved in that equation than we want. Once we get it, though, we can start visualizing it. We can start trending for it. We can start seeing notices on it. We have tools built into our suite to help with that on a regular basis. And these things are slicing and dicing. They're going to mobile devices. They're giving notifications. They're giving graphical views if your assets happen to be dispersed. There's a lot of different ways to visualize these and see what's going on. The idea behind it, giving your right people with the right tools at the right place at the right time, whether it's a capital plan, whether it's a CEO or a COO, or whether it's a field technician trying to find out what to do. This post-digital era will have a lot of opportunity to take that next step. So you have to say you see this coming. You know it is. You've seen this webinar, and you've read about it from other sources. You read about it from other analysts. You keep hearing about this data set coming, this wave and tidal of data and how it's structured. You're wondering, are my people ready? Are my people ready to really handle this? Because it could be in a situation where I get all this stuff, but man, it's just too much. I can't keep up, or I don't even know what to do with this data. And that could be a dangerous thing. So I started to look and see, okay, I did a quick review. This is my own research. I don't want to point to on the web. I put my sources down, but I went out to go say, hey, how is the environment, this particular ecology of asset management and maintenance? Are we getting graduates out there that are back into the science and technology degrees, the engineering degrees? And we do have, in this particular review at least, it was from 2009 to 2010, a small one in the 15 to 16, there was growth that was coming out, and that's a good thing. But we started to take a look at the growth of where it's at, what's coming with it, engineering degrees versus humanities degrees, trends that we have. It's going to engineering degrees are going up, and that's a wonderful thing. What's frustrating is a lot of those degrees, what's frustrating, again, and a blessing and frustration at the same time, is data is coming out where these degrees that are being produced are data science degrees, big data problem degrees, really heavy statistical degrees. So if you have a kid that's looking at going into college soon, like I do, I got him into statistics early and try to get them to understand the probability factors, different types of models, Weibel-Laplace, Markovian, Mercato, all these different types of things that are out there, because data science is an opportunity. At the same time, it can be a frustration for people that are trying to run business in the asset management plan, because you're missing the basic engineering. As it's becoming more difficult to get an electrical engineer, mechanical engineer. It's getting more difficult to come up with basic trades than it has in the past, because as we evolve in this post-digital era, you're getting more sophisticated pieces of equipment. You don't have steam-driven stuff, clearly, and sometimes you don't even have traditional powered types of assets. They're doing different things. So becoming more and more of a need to determine that outsourcing practice. Is it something that you do look to outsource and go to the OEM and say, hey, I'm just going to negotiate a service level agreement that this is the percentage of uptime, and if it fails, this is the response. Here's the warranties, and here's how we're going to work out through it. Is there benefits to doing this? Is there detriments to doing this? Answer is always yes and no. Outsourcing budgets are probably going to increase in this time for you if you're not willing to take those engineering disciplines in-house, or not able to take them in-house. But that can be a good thing. It just depends on getting to the asset strategy where you don't have any interruptions in the asset. And it also can mean that you may have increases in tools, increases in parts, because typically when you work with an OEM, of course, what are they going to say? You want to use their parts. They want to use everything that's their parts that were designed for that piece of equipment. The aftermarket purchase of materials for MRO especially may get damaged in this particular area because they are not providing the original equipment manufacturer recommendations. Whether that's good or bad could be argued, especially on a case-by-case basis. But outsourcing is an opportunity. It can also be a challenge. The idea, though, is go back to understanding who you are in your asset management strategy. What equipment do you need to keep running? What equipment is the most important equipment to the production process that you have? And source that correctly. It may mean that you have an outsourcing budget to that asset structure now. It may not. Look at the failure rates, what you've done, what you haven't done. Look at the service level agreements that you can put on the procurement side of your business to those assets. There's a lot that you can build into in this post-digital era. It's an opportunity for us for sure. The question, goes back then. So will advanced engineering now, if you're not outsourcing it, be required where the rubber actually meets the road? So out there, when you're looking at the asset, you're getting somebody down, am I going to have advanced engineering in my team? Am I not? And I say yes and no to this, because if you look at this symbol, I guarantee you 70 to 80% of you on the phone, if not more, know what it is. If you look at this, you're probably thinking, I see that on my car every now and again, and you're right. This is an indication of a low pressure on your car. So the low pressure on your car tells us that the tire has a low pressure, and it's a possible failure is going to happen. And why is this? What's this got to do with, am I going to need the advanced stuff? Well, think about it again, one more. This, I'm sure you've seen this too. This is a printer telling you how to replace ink, how to do maintenance on it, how to be able to repair it. This has changed from way back when. If you look into this particular bit, this was a calibration workflow that was done on a spectrometer a long time ago. It's very difficult. It's difficult to read. It's difficult to understand. It's difficult to implement. It's a hell of a lot easier than what you saw on just a little image that came up that the tire pressure is low, or looking at an image where the ink needs to be replaced and walking you through step by step how to do it, right? So the idea behind this is that if I'm going in this direction as an engineering organization, and I need to get a third party, I possibly do, and there may be different verticals that demand it more than others, but the systems that we're getting out and the data that we're getting out could be prescriptive. They could be telling us how to fix themselves. They could be telling us the right things to do. And these are things that we could typically see maybe, again, with tire gauges in cars or printers are a basic example of that. But you could actually get to a piece of equipment today that's complex, and it can tell you where to repair it. It can tell you how to repair it. And it can actually produce a response like a work order creation or preventive maintenance check option or path to fix it. So the question is, are you going to need advanced engineering in your employ? And the question is maybe not. Maybe as we start to evolve in this post-digital era, it's going to be easier to understand these equipment. It's going to be easier to operate, and it's going to be easier to maintain. Odds are not good for every piece of equipment, right? But you're definitely going in that direction as a general standard for sure. So finishing up a little bit further is understanding, is this a new concept? Of looking at the evolution and looking at going back to focusing on things that matter and looking at focus on reliability and going back. Is it a resurgent? Is it something we've seen before? Is it new that's coming out? Is the whole idea of asset performance management new? And I got to say no. I do think it's an evolution. Mowbray, who's, in my opinion, the pioneer in reliability-centered maintenance and RCM approaches, had written a bunch and done a lot of work that many of us had followed on this. But his statement here is humanity depends on an ever-increasing extent to the wealth generated by highly mechanized and automated businesses. So we as this grows, we depend on it to be around on a more regular basis. We also depend more and more on services, such as uninterrupted supply of electricity, trains, and runtime. More so than ever, these depend on, in turn, the continued integrity of these physical assets. So the continued integrity of those assets is what's important. You're going back to the resurgence of the concepts of reliability, the concepts of reproducibility, sustainability. You're going back to efficiency, but you're looking at it as something that's repeatable. You can start to understand that asset and do more with it. So in our world, what we do is we look at maintenance as an evolution, as a maturity model. We start to look at, okay, where am I? Am I at the base stage of reactive maintenance, going back to that Industry 1.0 standard, fixing it when it breaks? Am I at the second or third stage, which is an opportunity to do preventive maintenance or set up at least an idea for doing preventive maintenance but haven't really got there yet? Or am I going into some more of the advanced stages that are predictive, consumptive, prescriptive, different terms, and how to deal with those? And the question is yes to all the above, because you're going to have assets. I've been in organizations that have stalwart assets that are over 150 years old, believe it or not, and still running today. And they're fabricating parts, of course, because they can't buy them anymore. But the idea is that they're still working on them today. They're still doing business with them. So what you need to do is conduct an assessment. We do this type of assessment called a methodology assessment to take certain looks at those assets and certain looks at those practices and identifying what you're doing where and where is the opportunity to be able to implement something more advanced or even something more basic. This is just a couple ideas. Some of the elements of EAM that you'll typically see are listed in here. Look at the second page. Some elements that are put into here. Data management techniques, technology techniques, governance mining that's put in. There's a lot of different types of ways that you can look at where you are on that stage of evolution. And it's going to vary. It's going to vary by asset type. It's going to vary by department. It's going to vary by discipline of engineering. It's going to vary by a lot of different things. But take the assessment, take the time to evaluate who you are and compare that and overlay that with who you want to be and what your equipment demands you to be. These are different things. These are very different things. Once you understand that, once you build in a model, once you build in an approach, a strategy for it, you can definitely put a process to it that's repeatable. There are a lot of processes out there. There's a lot of certifications that are out there. This one in particular is the ISO 55000. We like this a lot. There's a lot of ISO standards that are wonderful. There's other ones that are outside of that as well that are great. But find different standards that you can believe in. The plan, do, act, check. These are things that are basic, and you would think 101 type of things to implementation. But sometimes they're not. I mean, these are where you plan for what you're going to do. You do what you planned for. You act upon, or you check upon what you find, and then you act upon any type of change to that, and then reproduce it. These ISO standards could be like this. Could be applied to checking inventory out, checking tools out, doing a reactive job, doing a preventive job. In each one of those stages in this post-digital era, again, you'll be flooded with data sets. You'll be flooded with opportunity. The question is, what works best? Why does it work the way it does? And what can we do to help it? And as you start to go through, think about all the compliance initiatives that you have to deal with when you do this. So as you look into that post-digital era, there's an opportunity to get data, but is it the right data? 21 CFR 11 is one that's in the federal rules, not only federal rules, it's Code of Federal Regulations from the FDA, the Food and Drug Administration, how to be able to manage equipment that's good manufactured process piece of equipment. It protects the environment, it protects the people, it protects consumers, it protects a ton of different things to keep your assets running safely and their products at a high quality, right? So in doing that, there's elements that you could capture in data that could be done quickly and easily with the post-digital era, but there may not. As you start to look at other compliance and regulations too, there may be something that are based on communication standards. Federal regulations and different types of federal agencies, as an example, have this. FedRAMP status, that's built in as an example that we went through with the EAM, is pretty rigorous on how to protect data, how to flow data, how to secure data that's going through. In the post-digital era, these are things you got to worry about. That you got to think about. This is why you have to have collaboration in your implementation approach with people like the IT group. So if you're going to get this data and store it, how do you share it? How do you promote it? There's data protection laws that are out there. There's a ton of different stuff to think about that you may not have had to thought about before. So as you start to think and you start to look out into the future, I like this image in particular, and that's a closing image, because I think this image shows what that post-digital era is. It's not necessarily the Tom Cruise looking into a glass of a Minority Report, but the idea is there's a lot of data set out there. There's a lot of different ways to look at assets that you may not have done before. There's a lot of different reasons to look at those data sets and those equipment that you can do now that you couldn't have done before, and it's changing. The speed at which it's changing is phenomenal. Go back and think about the phone that you have right now, either in your hand, listening to me, the way you're listening to me, the way you've logged in, the way you get email. Just go 5-10 years ago, is that the same way? And that's just personal communication. Think about the assets that you're maintaining and all the different ways that you can get information about them, the different ways that you can order them, the ways that you can install them, the ways that you can monitor them. It's changing. It's changing fast. In this post-digital era that we're finding ourselves in now, there is a tremendous amount of obstacles because of the amount of data that's coming at you. But these obstacles are not obstacles. These obstacles, from what we have found, are opportunities to be able to do a better job about making your assets be who you need them to be, in a safe condition that you need them to be in, and in a plannable way. So I can be able to look to the future in my asset plan. I can look at the replacement plan. I can look at the capital plan. I can model out what happens in these models because I know the data sets now. Didn't know that before. When something failed way back when, I just had to replace it with whatever I could find, and just so I can get that job done. Lord knows how long that job would make. I could just get it going and have it run for a couple of days. Now I know exactly what to get, when to get, if I have that data set. In the post-digital era, you're going to have a lot of it. It's just your opportunity of where to take it. With that, I'll pass it back over to Kevin.
Well, thanks, Kevin. We appreciate the thought that you put into your presentation. And there's really no doubt that we're at a very interesting spot when you look at history. When you take the really equipment or machines like a pump that go back to ancient times, or things like motors that have been around for a couple hundred years or something like that, and that were traditionally maintained by means of almost a folk knowledge, and now that's being joined with really the very latest in the way of computing technology. So like you say, that's really going to change a lot of things. You have to imagine how more reliable cars are today than they were, as you mentioned, 10 or 20 years ago. They're not liable to so many transient breakdowns and such, but it's got to be a little intimidating when you are in a plant environment just full of equipment and machines, and the expectation that you mentioned that there will be no more downtimes. One of our listeners has written in and asked, how realistic do you really think that is, that in this post-digital era there will be no downtime at all, either as an opportunity to do periodic maintenance or as a measure of success? How serious are you about that?
It depends on the equipment and if it's capable of running while being repaired. And the way that assets are being created now, especially with their redundancy in, it is possible. It is possible to have a continual operation and not have downtime at all because it has redundancy in its operation, especially looking at the very basic systems of moving materials back and forth. You can have multiple motors. One goes down. I already have a redundant that's pulled into it. All I have to do is replace it, and then I don't affect the overall operation of that process. It really is going to depend on that operation of the asset itself. But over time, I think it's definitely possible to get to a point where redundancy, triplication, duplication even is going to help get us there. It's just a matter of time.
Well, thanks. Now, you mentioned and talked quite a bit about outsourcing maintenance as a future consideration. I can see that happening on kind of two levels. Someone could come in and take responsibility for maintenance on a grand scale, or we have a lot of equipment builders who are equipping their machines and their equipment so that information about the state of the machine can be projected back to the builder. Talk a little bit about how those relationships are evolving between OEMs, the EAM supplier, and the actual users in terms of how those kinds of situations will be moderated in terms of who's getting the data and who's expected to act on the data?
That's a good question. Who's getting the data has typically, in the past, what we've seen, been a point-to-point thing. So I gather data, it sends directly back to the OEM, and the OEM doesn't share it. They only share the actions. So we need to take this equipment down on Thursday between 2 and 3 o'clock in the morning to do a particular preventive maintenance run on or recalibration. Why? Well, that's just what our data shows. Where's the data? We don't have to show you that data because that's a relationship. Sometimes that happens. What we see now is that data can be produced and shared into a collaborative form factor, and that's what a data lake can do. A data lake can take that data, put it into an unstructured format, and you can then share it amongst people. We're seeing where that data goes and what you do change from being point-to-point to being something that's a collaboration. The relationships that we have with the OEM, the enterprise asset management provider, and the contractor that is independent of the EAM provider or the EAM owner and the OEM is coming into play as well, because the OEM doesn't necessarily have to be there, but they need to have a certified technician involved in it. Where that goes and who does work on it, it requires a lot of collaboration. And that's why I mentioned in the beginning, when you start off with this particular journey, especially in this era, there's a lot of data going different places. And is it okay to continue to be point-to-point? Do you want to see it? Do you want to share it? These are questions you have to ask about that asset, and you have to go back to what is that asset there for? What is it doing, and what kind of performance do I need to see from it? If I can reach that myself, that's wonderful. If I can't, I need to have a collaborative environment. Or I could say, no, point-to-point is just fine until those, we need to keep in check those cost elements of how much they're charging us to do what.
Thank you. Are there, Kevin, particular types of equipment or classes of equipment that you noticed introduce more complications or need more adjudication as to how the process will actually resolve itself?
There are in certain industries, highly technical industries, the high-tech manufacturing process, the life science manufacturing process. See a lot of those, of course, in aerospace. We see a ton of those types of equipment. Some of the discrete manufacturing, we don't see it as much as we do in some of those other industries. The types of equipment inside those are getting a lot more specific, a lot more specific in terms of what they can do in their production. And because of that, there's a lot of QMS systems that we can pull data from that connect to them. We are seeing some in those more technical and even scientific environments than we do in some others. Facilities, though, you would think that's you don't see a lot of that, but you do. There's a ton of things that we see now in HVAC systems. We pull a lot of building information models from the people who build buildings and make them very green and very lean. And we're running into situations now where people don't even need to have keys to go into their buildings. I see that in Manhattan not too long ago. Guys don't even need to have keys. They have an image recognition to let you into the door, so you don't need a doorman. You go inside the door, you go to the elevator, image recognition knows which floor you're on. It goes to your actual door for your apartment. It sees you and unlocks the door for you. Not only that, but inside there you have a kitchen that can tell you what it needs to order on a regular basis. So these types of equipment we would typically find in some of the more technical and scientific environments and verticals, but they're showing up everywhere. So it's really hard to justify or pinpoint exactly where you're seeing it more than others.
Well, thanks. I thought you did a good job in pointing to at least in a direction to go or to look. Now,
sure.
When people are justifying technology investments, optimization of processes is often cited. Reliability is often cited. But so often, the reason for the investment's justification is regulatory compliance. So I'm not surprised that one of our attendees asked a question about the compliance elements that you noticed in the presentation. When you think about compliance and regulation, do you see any new best practices coming into play in this post-digital era?
In security access and how information is shared, and compliance of how information is shared, not only from an integration standpoint, from one system to the other. You mentioned data going from, or we mentioned rather, data going from my own location out to an OEM. That needs to be secure in a big way. So lots of encryption, lots of secure socket layer communication, things like that go out to that OEM. There's also general data protection laws that come in from Europe, GDPR, that we need to take and understand the privatization of that data, because there may be some personal information, especially in life sciences environments where there's healthcare involved. We're seeing a lot of these regulations drive a lot of security standards in a big way. We're also seeing a lot of these requirements drive a lot of process security standards. What I mean by that, if you look at the pharmaceutical industry, we've always had 21 CFR 11, and whenever you have a good manufactured piece of equipment, you have to record down to the second when that asset was touched, to look at, breathed on, and who did it, when they did it, what the value was before, and what it is now. So the process security continues to go into play, I think, and that's just the process of ownership. You'll see that come with blockchain, right? That's building out. But we see a lot more security issues of data protection type of issues, integration security types of issues than we've seen before, especially when we push these out to devices. BYOB and bringing is not BIOD. BIOD is a completely different thing. BIOD is bringing your own device. There's a lot of concerns on data sensitivity, security, and how that gets pushed out to some industries.
Good. Another listener asks, we're talking about how we're taking these basic technologies that we've lived with for a long time and marrying them with this high technology based around eventually analytics and, as you say, artificial intelligence. Have you seen the roles within EAM departments change, or have you seen, or you can take it either way, Kevin. You can talk about how the software is changing or how the roles are changing within an EAM department in your experience.
So the software is absolutely changing because we have to have a system that does a better job with condition, risk assessment, criticality definition, as much situational awareness that we can get about that asset is where these systems need to be. So we've had to evolve those. The roles themselves, we've seen a little bit of change with those. You still have some of the basic stuff. I think the question is, do I need to supplement those roles? And what I mean by supplementation is I need to introduce new disciplines. Data scientists we talked about. We talked about advanced engineering. Do I need to take some of the roles that I have now and change them? So I definitely see the question of, do the roles change? And to an extent, I see that they are. But at the same time, the new equipment coming around definitely needs that. But you can't argue the fact that those roles also need to maintain the equipment that is not changing, is legacy, but is still critical to what I'm doing. So it definitely seems to have evolution within the asset management principles and the approach. I see some changes in roles, but I see more, at least in my going out in the field and experiencing, see people looking to add roles to their organization and not necessarily change them.
Good. We've got a question that just came in from a listener, Kevin, and I'd like to field it for you. They agree that preventive maintenance is the future, and they are a proponent of it. However, is preventive maintenance going to take over all work orders? Is there still going to be a place for regularly scheduled maintenance? What do you think will be the mix when it comes to, I guess at the most basic level, what work orders are issued to the maintenance department?
You want to field that? I thought you said you wanted to field that.
That I wanted to field it?
Yeah, I thought you said you wanted to field it. Sorry, I misunderstood.
No, I'm sorry. I must have expressed myself poorly. Where do you see the balance going forward between preventive maintenance and more traditional maintenance scheduling?
Thank you very much. Sorry, I misunderstood myself. Preventive maintenance is always going to be around. You're always going to start to build it through. Preventive maintenance is going to be a part of it. What I think is changing is that preventive maintenance is going to be eclipsed by prescriptive maintenance. And what I mean by that is that this post-digital era and monitoring, especially, being able to understand that particular situational awareness of that asset exactly the way it is could actually eclipse some of the things that we would typically do preventively. So if I can understand it's going to fail at a certain time, then these are the actions that I take. They just may happen to be preventive maintenance things, but there's also incorporating other things that the system could be telling us it needs to do. Change a bearing, lube a particular bearing a certain way, change a motor component in a certain way. A lot of those things that would typically be done in a preventive maintenance schedule now can be done in the prescriptive model as well.
Good. Kevin, would you say it's fair to characterize the place where many manufacturing enterprises are in terms of maintenance or even in their control systems? Is they're coming to the realization of all the data that they have available to them, and they're starting to compile it, as you say, into repositories where it can be accessed, but now they're facing the challenge of deciding exactly what to do with that data now that they have it?
Yes, and I use the word deluge all the time because that's what it is. It's a ginormous tidal wave of data that they can take and put somewhere, and they're trying to figure out what to do with it. I see that more times than not. When I look at new builds, new manufacturing locations, new facilities that are coming up that have monitoring systems from buildings and things like that, it's a lot more formatted and more structured. But when I look at some of the existing installs that are out there, and I look at new assets that are coming in that just have this wave of information, you'll have people that typically are just looking at it from one asset at a time, now looking at this huge mountain of data and trying to figure out what to do with it. It's a big challenge, but again, I think it is an opportunity to be able to understand the asset better. If you have the capability, you have the skills, and you can be able to handle it internally. If not, then we start to look at outsourcing that in a big way.
Good. It's not really a focus of today's webinar, but it is a big topic when it comes to just about any kind of software. How is EAM making the transition to the cloud? Has it revitalized the market the way the ERP market has been revitalized? Are companies, just talk a little bit on your experience with working with companies and what kinds of either opportunities or challenges are they facing when it comes to transitioning to the cloud?
Great question. So first on the product, we've been in the multi-tenant cloud subscription environment since 2001. So we've had a lot of experience on it, and we know how to move people, and our development process and release process has the same version in the cloud as it is on premise. So it's important for us to do that because we can then roll out releases, updates, and things like that without having to branch the code or do different types of things. So for us, we want to move people to the cloud when we can because we can provide updates and automations faster to them, to their environment. Because when we send them out, we can make them available to the on-premise install, but then they have time to take it and update it and move it in and things like that. So it takes a little bit of time. Migrating to the cloud, for us, we do a lot of cloud. We're actually the second largest customer to AWS behind Netflix. So it gives us a lot of visibility into a lot of their services and what they offer. So we always are changing the architecture of our application to make it to where it can be as zero downtime as possible so that you don't witness any downtime events that are brought into it. Customers have always been looking at the cloud. They've been looking at it in many different ways. Sometimes it's something like a Microsoft 365 or a Google Docs environment, and that particular opportunity is easy to move to the cloud culturally. When you look at the assets that you have that are critical to producing the revenue that you have in your organization, it's a little bit more sensitive. Especially if you look at some environments that are government environments, there's some terrorist questions to be involved. If I'm going to put out my public infrastructure to the cloud, I need to make sure it's protected, it's an environment. So there's a cultural hesitation, a fear of moving to the cloud. Our technology, since it's been in the cloud since 2001, we have pretty heavy details on how to move data sets to the cloud, how to move different types of configurations to the cloud, different types of reports to the cloud. So for us, from a technical perspective, it's not as big a deal. From a migration sensitivity perspective from our customers moving to the cloud, it's growing better in some verticals than others. Some verticals you would thought never would consider going to the cloud are starting to make that decision and make that leap, which is good to see. But it is a culture change for sure.
Good. One of our listeners has come in with a late question. Bringing in an OEM to help with equipment troubleshooting repairs has traditionally been a last resort. Is there a movement to utilize OEMs to maintain equipment that we are seeing? Where do you see that happening most, that tendency for the OEMs to put sensors on their equipment and take responsibility for maintaining their equipment over the long term? Maybe
right.
You could talk about that market a little bit.
You're right, man. I mean, it was always a last resort. We don't know what to do, we're going to call the OEM. That was always the situation. It still is. You still hear that come out from a lot of other people. But if we go back to the risk assessment and we go back to the models of looking at those assets and finding, I need this running all the time. I need to know, when I run a production line of X type of products or Y type of time in a Z type of framework, that I need to know that it's not going to fail. Am I confident doing that with the team that I have? And that's what I mentioned earlier about the roles necessarily aren't changing completely because they don't necessarily have those skills anymore. The equipment's become more advanced, so they have to call in the OEM to begin with to be able to meet those service level agreements. And that's where procurement gets involved to help establish what service level agreements are. Sometimes they become more expensive to do that, but that's a process that we see a lot more routine. And where we're seeing it is, again, going back to the prior question, is a lot more technical, scientific, if you will, type of equipment than we've seen in the past. Hospitals, for example, the MRI machines and CAT scan machines, those are overwhelmed with technical possibility. So you have to have the right types of people involved, and a lot of those can be outsourced, maintained in their calibration efforts at least. So we're seeing it happen a lot more frequent than we have in the past. We're seeing those discussions coming to procurement negotiation when we buy equipment, but at the same time, it really depends on when you're thinking about outsourcing to really understand what your equipment is and what it's about.
Good. Final question for today, Kevin. I've been really impressed by the educational efforts that a lot of the automation companies and other entities within industry are making to kind of fill this skills gap that you've talked about so eloquently today with new people to attract them to manufacturing. Have you been involved in any of those efforts, or just tell us a little bit about what the EAM industry is doing in terms of trying to bring those people into the mix who can work across this more fulsome set of technologies?
So a really great point. I like this one a lot. It's because as we change, the industry itself needs to get back to academia. Because academia is where we're getting out either the right engineering resources or the wrong engineering resources. And as I mentioned earlier, what I at least found in my limited research was sometimes we're getting out the wrong engineering resources. We're getting out the data scientists and not the trades. And why is that? Why isn't there a mix between the two? So what we found is we're trying to work through our Education Alliance program with different universities to introduce more of the enterprise asset management discipline. And I like that. We have partners also that have taken our application environments and configured them and then used them as curriculum to teach at colleges and universities. We have a partner out there called Stratum Consulting that built a configuration of our application for craft beer. And they did a implementation example at a college that was focused to them at least on what to do with an MIS system that's modern, that you can configure an application for a specific industry, vertical and micro-vertical, and roll it out, how it works and how you get detail out. It's more of an industrial engineering approach, but you can take that application of that solution set and put it in to educate. We're trying to do what we can to work through customers and through partners to reach out to colleges and universities to help introduce curriculum that is built upon engineering disciplines that are basic for asset management and reliability. And then also on top of that, you'll have different conferences that are starting to get more resurgence, at least from what I've seen, around reliability principles, around sustainability principles. Love to see that on a regular basis and getting more certifications that are brought in. Anytime we can get back to the roots of like what Mowbray spoke of on reliability-centered maintenance, I think is going to be better for all of us. Because again, it goes back to understanding your assets, what they mean, and what it means to take them to get reliable. And if you don't have that principle of education, that principle of an engineering, that basic understanding, nothing else will work. Nothing else will build upon that. Your decisions will be made a little bit more based on an emotional feeling rather than a data set, based on a science and based on an analysis that you bring into the mix. So you have to go after not only the college and universities, go after the configuration elements as we did to our systems to reach that particular level, but also a lot of the industries that we're seeing on the side and events that we go to are starting to introduce it as well. So we try to help out as much as we can whenever we can.
Great. Thanks, everyone, for the great questions, and I'd also like to thank our speaker, Kevin Price, for sharing his time and expertise. I'd now like to also extend thanks to our sponsor, Infor, for sponsoring today's event. And now that we're just about done, we want to hear how we did. The exit survey will pop up on your screen as soon as the webcast ends. Please take a moment to complete it because we use this information to improve our webcast. Finally, on behalf of Plant Engineering and Infor, we'd like to thank you for attending. We hope the webcast suited your purposes. This concludes our webinar for today. Thank you, and we'll see you next time.